Okay, in this video we're going to be looking at complex numbers, and what we'll be doing here is adding, subtracting, multiplying, and dividing complex numbers, and performing operations with the square root of negative numbers. First of all, let's introduce you to the imaginary unit called I. The imaginary unit, which is I, is defined as the square root of negative 1, where I squared equals negative 1. Okay? So if I is going to be the square root of negative 1, then I squared will be equal to negative 1. Okay, now the imaginary unit is used in this concept of what we call complex numbers. And these are special type of numbers here. They're written in the form of a plus bi. And it contains the real part, which is your a. The b, which is the coefficient of I, is your imaginary part. So, in example number 1, you want to determine the real and imaginary parts of each complex number. So like in the first one, we got negative 7 plus 8i, and I want to know what the real and the imaginary parts are. Well, the real part is the negative 7. And the imaginary part is going to be the coefficient of your I. In this case, is 8. So here the 8 is the imaginary part, the negative 7 is the real part. Alright, the second one, 4 minus 8i. Here the real part is the 4, and the imaginary is the coefficient of I. And in that case, it's negative 8. Now, number 3, we got 2i. And I want to identify the real part. Well, another way of writing 2i in complex form would be 0 plus 2i. So 2i is the same as 0 plus 2i. So from here, that real part would be 0. Your imaginary part would be the coefficient of I, which is 2. And then the fourth one, we have 5. Another way of writing that in complex form, or standard form for a complex number, would be 5 plus 0i. So here the real part is 5. Your imaginary part, that's just going to be 0. Because there's no I given in that particular example. So here it would be 0i. The imaginary part will be 0. Okay. So that's how we identify the real and imaginary parts for each complex number. Alright, now here we're going to add and subtract complex numbers. Now here, adding and subtracting complex numbers is basically the same as combining like terms. Now here you'll simplify by combining the real parts together and the imaginary parts together. So here if I have a plus bi plus c plus di, here I add the real parts a and c together for a plus c, and the imaginary parts together, bi plus di, that will give me b plus d with the I behind it. And then for subtraction, we subtract the real parts, a minus c, and then subtract the imaginary parts, that would be b minus d with the I behind it. Alright, so in these few examples, we're going to look at how we can add and subtract complex numbers here. Now in this case here, for number 1, we got 5 minus 4i plus negative 11 plus 17i. Well, I'm just going to group the real parts together. So here I'm going to have 5 plus negative 11. And then the imaginary parts, that's going to be negative 4i plus 17i. Now if I add 5 and negative 11 together, we're going to get negative 6 plus negative 4i plus 17i will be a plus 13i. So the sum of those two complex numbers here will be negative 6 plus 13i. Okay. Alright, number 2, we're going to be subtracting those two complex numbers. Negative 8 plus 2i minus negative 11 plus I. Alright, in this case we're going to group the real parts together. That's going to be negative 8 minus negative 11. Keep in mind we're subtracting the real parts together. And then we're going to subtract the imaginary parts together. 2i minus I. Keep that in mind. That minus sign means we need to subtract I. So now we're going to simplify this. Negative 8 minus 11. Negative 8 minus negative 11. That's like negative 8 plus 11. That's going to give me 3. Plus 2i minus a 1i will be 1i, or we can just say I. So that's going to be 3 plus I. Okay. And the third one, 7 minus 6 plus 3i minus negative 13 plus 12i. Now, let me show you the other way of doing subtraction of complex numbers. I'm going to bring over that 7 minus 6 plus 3i. Now, this minus sign, I'm going to distribute the minus sign. It's going to change the sign of each and every term to the opposite. So the minus sign will make negative 13 plus 13, and the minus sign makes the plus 12i minus 12i. And then finally, all I need to do there is combine all my like terms here. If I do 7 minus 6, that's going to be 1. 1 plus 13 will be 14. And then these like terms, 3i minus 12i. That's going to be a minus 9i. So the final answer there will be 14 minus 9i. Okay. Alright, next we'll look at how to multiply complex numbers. Now pretty much you have to use either the distributive property or use the FOIL method to multiply complex numbers. But here's one thing you need to know. Anytime you have I squared, that's always going to be equal to negative 1. So you want to replace any occurrences of I squared with negative 1. And that's because of the fact that our imaginary unit is the square root of negative 1, where I squared equals negative 1. So everywhere you see I squared, you have to replace it with negative 1. So like in example 3, we're going to find the products of the following. So for the first one, we got negative 4i times negative 5 plus 8i. So here we're going to use the distributive property to simplify this. Alright, so when I do negative 4i times negative 5, that's going to be a positive 20i. And then negative 4i times the plus 8i. Well, negative 4 times 8 will be a minus 32. And then I times I is I squared. Now again, we got I squared, so we need to replace that with negative 1. So I'm going to have negative 20i minus 32. And that I squared will be replaced with negative 1. So I got 20i minus 32 times negative 1. Now if I simplify that, I'm going to bring over the 20i and then do minus 32 times negative 1 will be a plus 32. So I got 20i plus 32. Now, in standard form, we write the real part first and the imaginary part second. So it'll be 32 plus 20i. Right, number 2 is negative 8 plus 2i times negative 11 plus I. Now here we got a pair of complex numbers that we're multiplying. So here we need to use what they call the FOIL method. And what that is this. I take the first term times the first term. Negative 8 times negative 11. That's going to be 88. And then the outer would be negative 8 times I, would be a minus 8i. The inside, 2i times negative 11, would be a minus 22i. And then last times last, 2i times I would be a plus 2i squared. Now, we know we got to replace the I squared with negative 1, but I'm going to start by simplifying this. I'm going to bring down the 88, and then combine these two terms here, negative 8i minus 22i. That's going to be a minus 30i. Then plus 2 times that I squared, we replace it with negative 1. And the negative 1 will make the plus 2 a minus 2. So I'm going to have 88 minus 30i minus 2. And then I can do 88 minus 2, which will give me 86 minus 30i. So the product of those two complex numbers will end up being 86 minus 30i. Okay, and number 3, here we got 7i times negative 4 plus 6i minus 5 plus 4i times 2 minus 3i. Now this first piece, I'm going to use the distributive property, but for this second part, I have to use the FOIL method. So let's start with this one by using the distributive property. So I'm going to distribute the 7i over minus 4. So 7i times negative 4 would be negative 28i. And then 7i times 6i would be a plus 42i squared. So that's the first piece. Now, this product I'm going to put in parentheses here. I have to use the FOIL method here. So in this case here, 5 times 2, that's going to be 10. And then 5 times the minus 3i would be a minus 15i. The inside 4i times 2 will be a plus 8i. And then last, 4i times the minus 3i will be a minus 12i squared. Now I'm going to go ahead and simplify. I know I need to replace the I squared with negative 1. So here, I know this I squared would be negative 1 and this I squared would be negative 1. Okay. So now I have negative 28i. This negative 1 will make the plus 42 a minus 42. And that's because I squared is negative 1. Now I'm going to distribute the negative over each term inside the parentheses here. So the minus will make the 10 minus 10. The minus will make the minus 15i a plus 15i. And this minus will make the plus 8i minus 8i. And the minus sign will make the 12i squared a minus 12i squared. Now again, I know I got to replace that with negative 1. So I'm going to bring the rest of this down, 28i, negative 28i minus 42 minus 10 plus 15i minus 8i. And then that negative 1 will make the minus 12 a plus 12. And now I can go ahead and combine like terms here. 28i, negative 28i, plus 15i will give me a negative 13i. Negative 13i minus 8i will be a negative 21i. And then negative 42 minus 10 will be a negative 52. Negative 52 plus 12 will be a minus 40. So this is negative 21i minus 40. And in standard form, it has to be written like this, where the real part is in front and the imaginary part is second. So it'll be negative 40 minus 21i. Okay. All right, the next operation will be dividing complex numbers. When dividing complex numbers, you do not want an imaginary number in the denominator. To obtain a real number in the denominator, you will always multiply both the numerator and the denominator of the quotient by the denominator's conjugate. Now, what do we mean by conjugate? If we have the complex conjugate of a plus bi, it's just simply going to be a minus bi. Here we just change the operational symbol from a plus to a minus. And also, for a minus bi, its complex conjugate will be a plus bi. We just change the minus sign to a plus. So in other words, we're just changing the operational symbol to the opposite. Alright, the product of complex conjugates is a real number, which is a squared plus b squared. That's the sum of the real part squared and the imaginary part squared. Not the bi squared, just the b squared. Okay? So in this case here, for a plus bi times the conjugate of a, which is a minus bi, we square the real part, which is the a, and then add to it the square of the imaginary part, which is your b. And the same thing here for a minus bi times a plus bi. That's going to be a squared plus b squared. Alright, so now let's look at some examples of that. Alright, in this one, we're going to divide the following and express the answer in standard form, a plus bi. In this case, you got negative 4i divided by 5 plus 8i. Okay. Now, the denominator is 5 plus 8i. Its complex conjugate is going to be 5 minus 8i. So we're going to multiply the numerator and the denominator by the complex conjugate of our denominator. And that complex conjugate is going to be 5 minus 8i. The numerator, we're going to have to use a distributive property. So negative 4i times 5 will be a negative 20i. Negative 4i times minus 8i will be a plus 32i squared. Now the denominator, we're going to have to, since 5 plus 8i and 5 minus 8i are conjugates, we just simply square the real part, which is the 5, so it's just going to be 5 squared, plus the square of the imaginary part, which is 8. So it'll be 8 squared. And notice in the numerator we got I squared. We need to replace that with negative 1. So I'm going to have negative... Sorry about that. So here we got negative 20i. And then that negative 1 will make that 32 plus 32 a minus 32. All divided by 5 squared will be 25 plus 8 squared will be 64. So in this case here, we're going to have negative 20i minus 32 all over 25 plus 64 will be 89. Okay. Now here in the homework, they're going to ask for this. The real part will have to come first. That negative 32 over 89 plus the negative 20i over 89 will have to be written like this. And we can write this, since it's a negative, we can write this as a minus 20 over 89 times I. Okay? So that's how we divide using complex conjugates. Alright, now number 2. We got negative 8 plus 2i divided by 4 minus 3i. Okay, and I realize this is a little bit small, so I'm going to write this so that you can see what I'm doing here. Now, the complex conjugate of our denominator, 4 minus 3i, will be 4 plus 3i. So we're going to multiply the numerator by 4 plus 3i, and the denominator by 4 plus 3i. Now, in this case, we're going to have to multiply numerator times numerator and denominator times denominator. So in this case here, we have to use the FOIL method here. Negative 8 times 4 would be negative 32. And then negative 8 times the 3i would be a minus 24i. The inner 2i times 4i, 2i times 4, that would be plus 8i. And then 2i plus 3i would be a plus 6i squared. Now, of course, that I squared has to be replaced with negative 1. The denominator, we just, since they're complex conjugates, we just square the real part, which is a 4, plus the square of the imaginary part. That's going to be 3. Okay. So now let's simplify the numerator. I have negative 32. Negative 24i plus 8i would be a minus 16i. And then negative 1, since I squared is negative 1, it's going to make the plus 6 minus 6. All over 4 squared will be 16, plus 3 squared will be 9. And now, if I do negative 32 minus 6, that's going to be a negative 38 minus 16i, all over 16 plus 9 will be 25. Now, in the homework, they're going to ask you to write it, enter it in standard form. So it'll be like negative 38 over 25 minus 16 over 25 times I. Has to be written like that in the homework. Okay, so those are just a couple of examples of dividing complex numbers here using complex conjugates. Okay, next we'll look at roots of negative numbers, and that's the last thing in section 1.4. In this case, the principal square root of a negative number is going to be defined by the square root of negative b equaling to I times the square root of b. And that's because the negative sign means that there's negative 1 there. So we can take the square root of negative 1, and that will be I, square root of b. Now let's consider the square root of 25 times the square root of negative 9. Now, before we take the square roots, we have to write this in terms of I. Okay? So that means Negative 25 has negative 1 in it, so I need to take the square root of negative 1. That's going to be I, so that'll be I square root of 25 times. Same thing for the square root of negative 9. There's negative 1 underneath that radical, so we can take the square root of negative 1. That's going to be I square root of 9. And then we simplify. The square root of 25 is going to be 5, so it'll be 5i times the square root of 9 is going to be 3. So I'm going to have 3i. And now I can multiply 5i times 3i. Well, 5 times 3 is 15, and I times I is I squared. And of course, I squared is negative 1. So 15 times negative 1 will be negative 15. Okay. Now, in this example, we're going to use that concept of removing the I before we simplify. Here we're going to perform the indicated operations and write in standard form a plus bi. Here we got the square root of negative 27 plus the square root of negative 48. Okay. First of all, we need to write this in terms of I because we do have negative signs underneath the radical. So I know the square root of negative 1 will be I. So here, the square root of negative 27 will be expressed as I square root of positive 27 plus square root of negative 48. That's going to be expressed as I square root of 48. Okay, now the square root of 27 and the square root of 48 are not perfect squares, which means we need to find a largest perfect square that can go into 27 and a largest perfect square that can go into 48. So with this one, if I go up to, let's say 7, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49. Using this table here that I've given you, I want to find the largest perfect square that can go into 27. And in this case, it has to be 9. Okay? Because 9 can go into 27 evenly. It can go into 27 3 times. So I'm going to have I times the square root of 9 times 3. And then for the square root of 48, I need the largest perfect square that can go into 48 evenly. It has to be 16. Because I know 49 would be too much. 36 can't go into 48 evenly. 25 can't go into 48 evenly. But 16 can go into 48 evenly 3 times. That's 16 times 3. And then I can take the square root of 9, which is going to be a 3. So that 3 will be on the outside where the I is. And this 3 remains underneath the radical. Plus, I can take the square root of 16 here. That's going to be 4, so I can pull the 4 in front of the I. And the square root of 3, well, the 3 remains underneath the radical. So here I got 3i square root of 3 plus 4i square root of 3. Here I got like terms. I can combine their numerical coefficients. So 3 plus 4 will give me 7. So I have 7i square root of 3. Okay, here's another example. Say we have something like this one. Negative 3 plus the square root of negative 7, that quantity is squared. Well, to do that, what I'm going to do here is write this as a factor twice. Because that exponent of 2 tells me that negative 3 plus the square root of negative 7 is used as a factor twice. And notice I got a negative sign underneath the square root symbol, so I know I need to have an I in front of that radical, because there's negative 1 involved. So this will be negative 3 plus, square root of negative 1 will be I, so I'm going to have an I square root of 7. And this is going to be done the same way, negative 3 plus I square root of 7. Because again, that has negative 1 in it. And from here, I'm going to go ahead and use the FOIL method here. So, first times first, negative 3 times the negative 3, that's going to be 9. The outer, negative 3 times I square root of 7, would be minus 3I square root of 7. The inside, I square root of 7 times negative 3 will be a minus 3I square root of 7. Then last times last. I times I will be a plus I square. Square root of 7 times the square root of 7 will be the square root of 49. Now here I'm going to simplify all of this. Bring this 9 down. Negative 3I plus negative 3I would be a minus 6I square root of 7. Let that out. This I square will become negative 1. And the negative 1 will make the plus a minus. And then I can take the square root of 49. That's going to be 7. So now I got 9 minus 7. That's going to be 2 minus 6I square root of 7. And that will be the final answer to that particular example. Okay, and the third one, negative 10 plus square root of negative 12 divided by 2. Now, underneath that square root symbol, there is a negative sign, meaning negative 1 is involved in there. So that means I can take the square root of negative 1, which will be I. So to start this off, this will be negative 10 plus I square root of 12 all over 2. Now, 12 is not a perfect square, but 12 does have a perfect square in it. So we need that largest perfect square that can go into 12, and it has to be 4. So I have negative 10 plus I square root of, and I'll write 12 as 4 times 3. Because 4 is a perfect square, it can go into 12 3 times. And all of this is divided by 2. Now I can take the square root of 4, which is 2. So I have negative 10 plus 2I square root of 3 all over 2. Now, I can divide negative 10 by 2, and then 2I square root of 3 can be divided by 2. Now, negative 10 divided by 2 will be negative 5 plus 2I square root of 3 divided by 2. The 2's divide out. You're left with just simply I square root of 3. So the final answer there will be negative 5 plus I square root of 3. Okay. Alright, and that will conclude this particular video on complex numbers.